All right, so today I want to talk a little bit about limits. Chapter 7 deals a lot with limits, and this is kind of right at the point where we're built to build a bridge to calculus. We're going to connect what we've been learning to a lot of concepts that you're going to study in calculus in the first semester next year. So it does start to get important. We do skip chapter 6, and that's because that stuff isn't really important to calculus. So we're going on to chapter 7, and we're talking about limits, which we've been talked about a little bit, but now we're talking about one-sided limits. Okay, so you'll recognize a one-sided limit when you see this little symbol. It'll be either a plus or a minus sign at it. And if I think of what does that function x over x minus 2 look like, I'll be picturing it while I'm fumbling around to get to the graphing calculator on Desmos. And you should know that it's like hyperbolic. You might know that there is a vertical asymptote. Again, that's what the function looks like. You might also know that there's a horizontal asymptote. You could know that you could do polynomial division to re-express it in some different type of way. In this case, all right, just since I mentioned those things, and you should be aware of them, then you would have a vertical asymptote at x equals 2, and a lot of times we see those as dashed lines. And you would have a y-intercept at maybe y equals 1. Yup. And I'll try to make it the same color in dashed also. But so when I'm thinking of what's the limit of this function as x approaches 2 plus, this plus right here, this plus means as I approach it from the plus side. Remember, on an x-axis, right? This is the plus side, this is the minus side. So that plus side means as I approach it from the right. And so in this case, as I approach it from the right, I'm traveling up this way. As I get closer and closer to 2, I'm approaching positive infinity. Okay, so this case would be positive infinity. If it said from the minus, notice that as I approach it from the left, it approaches negative infinity. Now, there is a debate that we won't settle that goes on in the math community about whether limits exist at infinity or they do not exist. For now, I'm going to put infinity, but think how silly it would be if you saw a speed limit sign that said speed limit is infinity. It wouldn't make sense. They couldn't write you a ticket, and therefore the limit doesn't exist, and therein lies the debate. But it is useful because I can distinguish between going to positive infinity versus going to negative infinity. And for now, that's what I'm going to do. And so for this one, again, I could put this into a graph. Y equals x plus 1 divided by and it was the limit as x goes to 3 from the positive side. So as we're going to 3 from the positive side, it looks like it does have, by the way, this is x minus 3 squared in the denominator. So it is going to have an asymptote at 3. So it looks to me like this is going to positive infinity. And in fact, it looks like it goes to infinity from both sides, positive and negative on that one. And I assume that's because in the bottom you have x minus 3 squared. And if you remember what we talked about with polynomials was when it had a squared function, it would bounce off of that. So if you think of what that would look like with the reciprocal, it would look like an asymptote with both sides going the same direction. Okay, I expect today's lesson will be a bit confusing, like a lot of them. Hopefully it'll make more sense as we come back to it over the next couple of days as we talk about limits. Sometimes you might get a question. Let's talk about how you do these things algebraically. Sometimes you might get a question like this that says, Find the limit as x approaches 3 from the negative side, and it's a piecewise function. And you're like, all right, well, all I got to do is plug that in. But which function do I plug it into? Well, from the negative side, remember, is when x is less than 3. In this case, x is less than 3 is the top function. Okay, so that's the left. So it would equal, what would this be? Negative 3 plus 4, which is 1. Okay, from the if it said from the other side, I'd plug it into the other equation. This one says it's coming from the right side. Okay, this one said it's coming from the left side. The right side means when x is greater than negative 1. So that's in this case. So I would say negative 1 minus 1, which is 0. So in that case, the limit would be 0. That's how you would do these algebraically if you're given a piecewise function. Oftentimes, you might be given a picture that looks like this, and now you're asked to evaluate a bunch of different limits. Okay, so the rule for the limits is, or for the function is, f of 0 exists if it's coming to the same part from the left point as is coming from the right point as is the point there. So does f of 0, well, let's just look at f of 0 before I explain that rule more thoroughly. But f of 0 does not exist, right? Because f of 0 is a hole, an empty hole. So I'm going to put D N E. F of 2 exists. Where does f of 2 exist at? F of 2 is right there. It's 0. F of 3, what's f of 3? F of 3 is where the closed-in circle is. So f of 3 is equal to 3. Now, what's the limit of f of x as x approaches 0 from the minus side? Okay, that looks like it's going there. It's going to be negative infinity. What's the limit as x approaches 0? So this is what I was trying to say before that I fumbled on my words on. So see how the limit as x approaches 0 from the minus is negative infinity, but the limit as x approaches it from the plus is 2. So if those two things, if the left and the right are not approaching the same thing, then the limit at that point does not exist. And that's important. And the next one says, what's the limit of f of x as x approaches 3 from the plus side? As x approaches 3 from the plus side, we're going to 2 on the y-axis, okay? What's the limit as x approaches 3? Well, notice that as we approach it from the plus side, we're going to 2. As we approach it from the minus side, we are going to 1. Those are not the same point. Therefore, that limit does not exist because on one side is different than the other. Okay, what's the limit of f of x as x approaches negative infinity? Well, that's going out this way on the x-axis, and that looks like it's 1. Okay, so you may have to do those, and you may have to make sense of them, and it may not make sense right away, but it will. Eventually it will, I promise. And then one other trick that is often, you'll see these problems, and you'll be like, I don't know. It's either going to have a hole there, or it's going to have a asymptote. If it has an asymptote, the function doesn't really exist. But if it has a hole, there is a limit. So what you'll think to do is factor to see if you can factor and cancel. And in this case, I can factor the bottom into x minus 5 times x plus 1. And I can factor the top into x minus 5 times x plus 5. And what happens is you can cancel the x minus 5. Okay, and what that means is that this function is exactly identical to x plus 5 over x plus 1, except for at one particular point, and I'll show you what that one point is. But when I plug in 5 to x here, I get 5 plus 5, which is 10. I get 5 plus 1, which is 6. 10 over 6, which is 5/3. And so if I, which is also what, 1 2/3? 1.67. So if I look at what this function looks like on Desmos now, y equals x squared It looks like this x plus 5 over x plus 1, but I told you there is one point where it's not exactly the same. And let's see, I want to see if I can actually get the calculator to admit that one. Let's see, if I say f of x and I say f of 2, it'll tell me what f of 2 is, right? If I say f of 1, it'll tell me what f of 1 is. If I say f of 5/3, oh, if I say, that's what it is. If I say, not f of 5, I want an f of 5, okay. And I should be able to get 5, undefined. Okay, so that's the one point that's different. If I, at 5, it's undefined, whereas if I had the function x plus 5 divided by x plus 3, sorry, x plus 1, at 5, I would not get an undefined. I would get 2/3. So that's the one difference between those two functions. But the limit, so we would say the limit still exists. It's just the function is undefined at that point. And then since I always like to leave you guys confused and thirsty for more, I'm going to show you how you could do a very, I would say, higher level factoring and cancel problem, which you may have to do at some point. But if you're like, why the heck is he doing what he's doing when I'm doing this? That I think is understandable. So this is a situation where you can factor and cancel, but you have to know what to do. And what I'm going to do is I'm going to multiply this thing called the conjugate. So a minus b times a plus b is equal to a squared plus b squared. That's a convenient thing in a lot of higher level math. It's a convenient rule that you just have to know, and it often gives you tricks that help you circumnavigate unwanted roadblocks. So in this case, I'm multiplying both the top and the bottom by the conjugate of the square root of x minus 2, which is the square root of x plus 2. I'm actually not going to do anything on the bottom because that would be a hot mess. But on the top, what I want to do is I want to multiply. This is a minus b. This is a plus b. So I can use that pattern to just go straight to, without having to do all the middle stuff, that I'm going to get a squared. Well, what's the square root of x plus 1 squared? It's just going to be x plus 1. So I'm going to have x plus 1 minus b squared, which is 4, divided by x plus 3, x minus 3, square root of x plus 1 plus 2. What does that become? That becomes x minus 3 divided by x plus 3 times x minus 3 times the square root of x plus 1 plus 2. Okay, at this point, if I plugged in a 3, what am I going to get? I'm going to get 0 over 0. Okay, that's why I can't just plug in 3 at the beginning. If I plug in 3, I get square root of 4, which is 2. 2 minus 2 is 0. 0 over 0. At the point that I get to here, where I can cancel out one of the factors, now I can plug 3 in. Now I can get a number, and what am I going to get? I'm going to get 1 over 6 times square root of 4 is 2. 2 plus 2 is 4, so I get 1 over 24. So I would say this is like the highest level limit question you're going to get. You may feel like it was unfair of me to introduce it in the first video. I'm like, whatever, cry somewhere else. But it'll make more sense as we get into this and as we do this stuff more often.